So this video will provide a brief overview of some of the stuff you're going to see in Chapter 1 for the Calc 1 class. So this chapter is basically a review of stuff you've seen before. So you get, first off, in terms of functions. So remember, for a function, that was for every x, you only have one y value. So that's what made a function a function. And then you had, in terms of the other terms you've seen before, domain, which basically was the x numbers, which is basically what numbers can you plug in. So what numbers can you plug into your equation? Let's redraw that. Try that again. What numbers can you plug in? And then the range, which were what numbers come out. So, for example, if I had something like this, f of x equals x squared plus 2x. Well, the domain, the numbers that I could plug in would be all reals. So negative infinity to infinity in terms of that notation. And then the range would also be all reals. So negative infinity to infinity. Right. And then if I had one that looked like this, equals the square root of x plus 2. Right? And as a domain, so domain here, remember we can only take square roots of numbers that are 0 or positive. So here my domain is going to be negative 2 to infinity. Can be negative 2, that's why the bracket. And then the range, because we are talking about the square root function, remember that meant we're only talking about the positive answers. And so this would be 0 to infinity for that. Other things you've seen before are those things called composite functions. So, for example, let's say that f of x is going to be x squared plus 2x. And then g of x is going to be 3x plus 2. And then we could do fog, f of g of x. And remember that meant is you started with the f first. Everywhere you saw the x, you plugged in the g of x. So this became 3x plus 2 squared plus 2 times 3x plus 2. So this ends up being 9x squared plus, and this will be 12x plus 4 plus 6x plus 4. And so this could be simplified. This will be 9x squared. 12x and 6x will give us 18x. And then plus 8. Right? And then we could do this the other way and do cof. So now this says start with the g. Everywhere you see the x, plug in the f of x. So this is now going to be 3 times x squared plus 2x plus 2. So this will be 3x squared plus 6x plus 2. So we had in terms of that. Right. Other things you've seen, and you had this thing. So you had what was called the difference quotient. And that was f of x plus h minus f of x over h. And so let's say I want to find the difference quotient for x squared plus 2x. So f of x is going to be given by this. And so we need to know what is f of x plus h. So this will be x plus h squared 2 times x plus h. So this will be x squared plus 2hx plus h squared plus 2x plus 2h. Now we can take those pieces and plug them into that formula. So we have x squared plus 2hx plus h squared plus 2x plus 2h minus the x squared plus 2x all over h. And of course now I can do some canceling. So the x squared and the x squared and the 2x and the 2x. So we're left with a 2hx plus h squared plus 2h all over h. But then, of course, h is common to every term on the top, so I could factor an h out. So you get h, this will be 2x plus h plus 2, all divided by h. And then now the h's go away, and we're left with a final answer of 2x plus h plus 2. Well, then this chapter talks about there are different types of functions, and you've seen these before. And so it goes through a list. So you had linear. So f of x equals 4x plus 3. Rational functions. So f of x equals 2x minus 7 over x plus 3. Algebraic. X plus 9 times x plus 3 plus 2x squared plus 3x. Exponential functions. So f of x equals 4e to the x. And trig functions. So f of x equals 4 sine 2x plus pi. So different types of functions. Right? Other types then, there's a thing called a piecewise function. So example, that would be like if I had this f of x equals and x plus 2 if x is less than 3 is 5 if x equals 3 and x squared if x is greater than 3. Right? So if I ask, for example, what is the f of 0? Well, the f of 0 would be 2. The f of 3 would be 5. And then the f of 7 would be 49. Right. Other things which you've seen before is in terms of manipulating graphs. So in terms of moving them up, down, left, right, that sort of thing. So if you think in terms of your basic quadratic graph, which was this one. This is your y equals x squared graph. You should remember then in terms of how to do all this kind of stuff, y equals x squared plus 2, y equals x squared minus 2, y equals x minus 2 squared, and y equals x plus 2 squared. So basically what this did in terms of stuff is this moved it up 2, this moved it down 2, this moved it to the right 2, and this moved it to the left 2. Right? So those sorts of things. Right? Other things in terms of graphs you had in terms of your basic exponential graph. And my exponential function. So y equals b to the x, and b is greater than 1. And so that was my graph that had this shape. And then you had your logarithmic function. So y equals log base b of x. Right? And so that was this graph that went like this. Right? Right? So we had a function that said that for every x there is only one y, and then you had in terms of is a function 1 to 1. So in order for a function to be 1 to 1, you have the first off for every x only 1 y, and for every y only 1x. Right? So that was 1 to 1. Right? And so remember that in terms of testing whether something, so let's draw a graph. So let me draw a graph here. So let's draw my basic quadratic. So I had this. Well, I asked if that was a function. It is a function, but remember it passes my line test. Right? So if I take a line, so for example, if I take a line going like this, I pass that line everywhere through that graph. It only cuts the graph every time in one spot. So it's a function. Okay. Now, in order for it to also be 1 to 1, it also has to pass the line test going this way. Right? So it has to pass those the vertical and horizontal line tests in order to be 1 to 1. Okay. Other thing regarding to functions, you have what are called inverse functions. So, for example, if I had y equals 2x plus 3, and I now want to know, well, what is the inverse? Well, to get the inverse, I flip-flop the x's and the y's. So x equals 2y plus 3. And now I'm going to solve this for y. So we have x minus 3 equals 2y. And then I can divide by 2. And so we end up with x minus 3 over 2 equals 1. And so we could say, okay, so f of x was equal to 2x plus 3. And my inverse, so it's a little minus 1 is 4, is x minus 3 over 2. Right? Right? And let's see, the last thing it finishes off with, and again, it's stuff you've seen before, are the trig functions. Right? So again, you had in terms of the exact values. So remember, in terms of pre-calc 1 and 2, you had in terms of 30, 45, 60, those angles. Right? But then also if I had something like this, 3 sine x plus 2 equals 0, I should be able to solve this. And so here, first thing I do is subtract 2. And so we get 3 sine x equals negative 2. Then I could divide by the 3. And so sine x equals negative 2/3. But I want to know what the angle is. So that means that x is going to be the inverse sine of negative 2/3. And that we could plug into a calculator. If you do that, you end up to be basically a negative 41.8 degrees. Which would be, if you think in terms of where that would be, negative 41.8 would be somewhere down in here. And so the positive angle, that would be the same thing, is going to be 318.2 degrees. But sine, there would also be another one in the interval between 0 and 360 degrees, and that other angle would also be over here, where this is 41.8 degrees. And so the other answer here is going to be 221.8 degrees. Okay? So within the interval of 0 to 360, there are 2 answers here. Okay? And then the other thing you've seen before was in terms of graphing trig functions. So y equals a sine or cosine bx minus c plus d. And remember, when it was in this form, the amplitude was given by the absolute value of a. The period was given by 2 pi over b. The phase shift was c over b. And then up or down, the whole graph, was given by d. So that is a brief overview of that stuff you'll see in that chapter. And that will conclude this video.